Hello everyone, welcome to the topic Relations and Functions. Here we discuss composition of functions, FOG, GOF and inverse of a function. Now, a function f defined from set of real numbers to set of real numbers defined as f of x equal to x for every x belong to set of real numbers is called identity function in set of real numbers and is denoted as IR. That is, image of 4 is 4, image of 2 is 2, f of 0 is 0, f of minus 1 is minus 1. In fact, I of 2 is 2. The f is renamed as I. That is what identity function. I of x is equal to x itself. That's a very special function. Let's have a look at the graph of this function. I of x equal to x means y is equal to x, which means y coordinate will be same as the x coordinate. Let's try to plot all such points. X coordinate is and y coordinate are equal. So the points are 3, 3, 2, 2, 1, 1, 0, 0, etc. And it's quite obvious if you plot those points, they will all fall on this straight line. This is the graph of identity function. So identity function is I of x is equal to x. In other words, y is equal to x. A function f from set A to set B is defined to be invertible if there exists a function g from B to A such that GOF is equal to IA and FOG is equal to IB. Then this g is called the inverse of f. Look at this definition once more. A function f from set A to set B is called invertible if there exists a g from B to A satisfying two conditions. GOF, the composition of these two functions in the order, GOF should be identity function of set A and FOG should be identity function of set B. If there exists such a function, we call this f is invertible. And this such a g, if it exists, is called the inverse of f. G is called the inverse of f and denoted as f inverse. This g itself is the inverse of f if it exists. Now notice one thing. Let's take an x element in set A. Then f of x will be in set B because f of x means image of x under the f rule. F is defined from set A to set B. So the image will fall in set B. Now since f of x is an element in set B, it will have an image under the G rule and the image will fall in set A. So G of f of x, G of f of x will be belonging to set A. G of f of x will belong to set A. And what is this G of f of x? This is what GOF composition. GOF of x belongs to set A. So notice one thing. We started with an x in the set A. F of x we found in set B. Then G of f of x we found in set A. So G of f of x is in set A, which is what? GOF of x. So we take any x in set A, you get the image in set A itself under this rule GOF. That is why GOF should be identity function in set A. GOF is identity function in set A. Now, let's look at another way. Take a y element in set B. Start here. If y is an element in set B, G of y is possible since it is a function and it will be found in set A. G of y, the image of y under the G rule will be found in set A. So G of y will belong to set A. Now, G of y is an element in set A. So f of g of y, the image of g of y, this element under the rule f, will be found in B. So f of gy belongs to set B. Now, what is this f of g of y? This is nothing but f of g of y. So, we took a y element in set B. Its image g of y we found here. Then f of g of y we found in set B itself. So, this f of g takes an element from set B back to set B. That is why f of g function is taken to be the identity function in set B, from B to B. So f of g is identity function of set B. F of x is equal to 4x plus 3 upon 6x minus 4, where x is not equal to 2 by 3. Show that f of x is equal to x itself. And what is the inverse of this function f? Let's first find out f of x. F of x. What do we mean by f of f? It's a composition of f and f. And its definition goes this way. If f is from a to b and g is from b to c, GOF is defined from A to C as GOF of x is equal to G of f of x. GOF of x is equal to G of f of x. This is the rule we need to follow now. So, f of x is f of x. f of x is f of x. That is what this definition says. Now, f of x. Let us replace this fx with this complete rule, this as an element here. So the step will be written as this. The f function says 4 times the element plus 3 upon 6 times the element minus 4. 4 times the element plus 3 upon 6 times the element minus 4. This is the rule for this f function. F of x. So what will be the element here and here? Both should be f of x. And what is f of x? F of x is this whole expression. This whole expression should be treated as one element and placed here and here. So it goes this way. 4x plus 3 upon 6x minus 4 in this bracket, as well as 4x plus 3 upon 6x minus 4 in the next bracket. This is what f of x. Let's simplify it. LCM and simplification gives 4 into 4x plus 3 plus 3 into 6x minus 4 whole upon 6x minus 4 over 6 into 4x plus 3 minus 4 into 6x minus 4 over 6x minus 4. The denominator same 6x minus 4. Simplify further. 16x plus 12 plus 18x minus 12 upon this whole thing. Club the like terms. 12 and minus 2, 0. 18x plus 16x, 34x. Minus 24x plus 24x, 0. 18 plus 16 is another 34. So we are getting it is equal to x, which is what we wanted to prove. F of x is equal to x, yes, we could get. That part is fine. Now the question continues, what is the inverse of f? How do we go by that? We need to refer to the definition of f inverse. Here it goes. If there is a function, the inverse is that function g which satisfies these two equations. GOF of x should be equal to x itself. That is, GOF should be identity function. F of G also identity function. Look here, this FOF of x is equal to x itself we got means this FOF is identity function. Any element's image is the same, which is what the definition of identity function. So we have got FOF is identity function. Now compare it with this new definition of inverse. GOF should be identity. GOF should be identity. So in place of G, you can place this F itself. Also, FOG of FOG is equal to identity function. That means this function O, this function equal to I. So in place of G again, it is F itself. Comparing with these two definitions, these two equations in the definition, this equation tells us F is the inverse of F. That's what the function says here. Definition says here. If GOF is I, identity, and FOG is identity, then this G is called the inverse. This kind of an equation we have it now between F and F. F of F is identity. If we want, we can reverse and say F of F is identity once more. So in place of G, we notice F itself. So we conclude F is the inverse of F. This F is the inverse of F. So the conclusion is this function itself is the inverse of this function given function.